morning to our First in Texas teams and students. I'm Susan Ashmore, the Development Director for First in Texas. We have a very special program for you today with our panelists from Texas Instruments. I know many of you mentor teams in your own community and across the globe. Did you know students who regularly meet with their mentors are 52% less likely than their peers to skip a day of school and 37% less likely to skip a class? In addition to better school attendance and a better chance of going on to higher education, mentored youth maintain better attitudes towards school. Lastly, mentoring provides positive social attitudes and relationships. So now to meet our panelists. Eduarda Ferreira has a BS in Mechanical Engineering from the University of Central Florida. She is a mentor for FRC Team 6526, the Cyber Rangers. Next up is William Go. He has a bachelor's and a master's degree from the University of Florida in Electrical Engineering and Civil Engineering. He is a mentor for FRC Team 3005, the Robo Chargers. Our third panelist is Asheesh Bhardwaj. He has a bachelor's in electrical engineering and a master's in digital signal processing from the Indian Institute of Technology in Kanpur, India. And he mentors FRC Team 5417, Eagle Robotics, and FLL Team 47405, the Cloudy Bots. Our fourth panelist is Steve Clynes. He has a bachelor's in electronics and electrical engineering from the University of Glasgow in Scotland. He is a founding member of FRC Team 5242 Woodrow Wilson RoboCats, and he mentors 4 FTC teams at Woodrow Wilson High School. Last but not least is a true First in Texas champion. Harshal Chhaya has a bachelor's in electronics from the University of Mumbai in India. He also has a master's in electronics and computer engineering from the University of Illinois. He mentors FLL Team 46545, the Bethany Builders. So let's get started. So first question, how would you describe your mentorship style? Steve, why don't you kick it off?
Okay, so hopefully easygoing and fun, but kind of no holds barred. I try to asking a lot of questions, a lot of what ifs. I'm very, very hands-on. I like to experiment with things and, kind of hold things in my hands and have, a very physical kind of learning process. Especially if I'm not entirely sure myself. I kind of try to, like I said, just be very, very hands-on. I'm not huge on doing everything theoretically first. I use a whiteboard a lot, and for things like springs, etc., it's really difficult to get a feel for how a particular piece of machinery behaves from a purely theoretical perspective. So I like to be very, very hands-on and just kind of try and keep things as fun as possible.
Very good. What about you, Asheesh?
First of all, I would like to thank first for giving me the opportunity to mentor smart kids. We have really good kids out there. Where I do mentor students they range from elementary to middle to high school, and to achieve the first challenge. But the way I mentor that, I give a lot of free space to the students to think themselves, to be curious, to be creative, to be innovative. So for me, it is like they have a very blank blackboard on which they can draw whatever they want. But I do provide them their end goal and what they have to achieve. And specifically because I'm fundamentally a programming mentor, I give them a good end goal and a challenging solution and a challenge which they can go ahead and solve problems in different manner. So I just give them a free space and they can think themselves, come with creative solutions, and then we review that and then we go ahead and implement it. So I just love the way to give more freedom to the students to be innovative and come with a very good solutions towards the end.
Very good. So our second question is, what are the skill sets required to be a mentor other than technical skills? Harshal?
Yeah, so that's a good question. I know others might have their own viewpoints, but I think I've been working with students who are interested in learning more, and so I think the big feature, even more I think than technical knowledge, is an ability to foster curiosity. Is without jumping in and without trying to solve the problems, as I think as both Steve and Asheesh mentioned, is sometimes we may be tempted to jump in, but let them try, let them learn on their own, and they may fail. One of the great things about programs like FIRST is it's a safe space to fail during the season where you're trying out new things and you have the opportunity to learn, make mistakes. And then, of course, understand, what their background is. Just because we all have advanced degrees and we understand something that's obvious, a fifth grader, a seventh grader, even a 12th grader does not have the same background or the same context. And so, trying to think why they are struggling with something is, empathy, if you will, is really critical in trying to kind of get down at that level, but also encourage them to strive harder and try something different.
Okay, very good. William?
So to be a good mentor, I would say even to be a really successful mentor, right? So the way I see this and approach this to a lot of our students here is the key thing is listen to them. And the most important part is really understanding what their key concerns are, what their key challenges are, and how can we help them? How can we address them? How can we, make them successful, right? So let's say, hey, I want to build a brand new XYZ arm, for example. How do we help them to guide them from step by step, from the beginning process all the way to actually having them taking ownership to fabricate it, to make it, to actually give them the sense of ownership of making something, right? I think the key thing here is that let them make the decision, right? Your goal is to help them, to guide them as much as you can when they're stuck. Be observant to see when they're stuck and try to step in as much as you can and as soon as you can to kind of unstuck them, to help them to move on, to keep progressing forward. And this is where, we as a mentor can really come in and help there. Like what you were mentioning, Harshal, like showing empathy, showing patience to them, right? They're going to struggle because they're new to this. They don't know what they're doing yet. So your goal is to be as patient as possible, to show empathy that, hey, take a step back and say, okay, let's see what the problem is and try to help them from there, as you go. To then also be cognizant as to understanding what, if they have any personal issues, personal problems that they're trying to resolve. Also, aside from just the robotics itself, we do have a good group of students like this, right? And try to see how we can help them, not just about the technical side of the skills, but also maybe help them and guide them on maybe they have some personal problems that we need to help and guide them to be successful from that aspect also.
Eduarda, what do you do to bring out the best in students?
So my main strategy to bring out the best in students is by inspiring them and giving them a big picture view of what the robotics competition is about, which mainly is to help them develop skills, technical and non-technical, that they can use to advance in their careers in the future. So very often I try to suggest the new skills that they should learn, let's say CAD, programming, leadership, and how that will also help them in the future when they are applying for a job. So they are aware that they have these skills and they know what they should pursue to help them. And when it comes to inspiring, it's very common for the robotics students after they were exposed to robotics to want to become engineers. And I'm a mechanical engineer myself, and I see that they see me as a role model. So I try to take advantage of that to inspire them to pursue a career in engineering. But also multiple times during our team meetings, I have brought up coworkers from different engineering backgrounds, let's say electrical and computer, that also served as inspiration to those students that were that wanted to pursue a career in these fields. And it was very good to see the students interact with them and how proud they were to show what they have accomplished, and also get feedback from people that they inspired to be like in the future.
Very good. Steve?
So yeah, I always try to push the student, you know, especially if I know that they're capable of doing something or answering the question or solving the problem or whatever we're working on. You know, especially with new or shy students, they'll often have great ideas but are afraid to voice them. So I try to push them and encourage them and get them to kind of bring out their ideas. I think my style changes obviously a lot depending on the student, but I really just always try to kind of push them and keep them thinking. I tend to ask a lot of leading questions that might end with and you know, kind of keep trying to push the thought process. This way, kind of more often than not, the student will actually get to, you know, a valid solution at the end of it. The advantage of that, though, is that they have the joy and the satisfaction of they did it. They answered the questions themselves. You know, I will say sometimes I have to do a lot of leading, but I still try and just push the student to the end result and try and make them come up with the answer. And it's great at the end when you know, I call it that eureka moment or the penny drop moment. It's like, you know, oh wow, you know, when they make a link between things, or you know, if you've just told the student that this is how it works, it doesn't have quite the same impact as if they, you know, even though you've led them to that solution, when they make that mental, you know, link between the two, I think it has a much more dramatic impact. So I just, you know, kind of fundamentally, I just try and push and lead the students to the answer, or to an answer that solves the problem.
How do you encourage innovative ideas and solutions? William?
So the way I approach this on our students here, right, is telling them, hey, don't be afraid to be wrong. You know, there's no right answer and there's no wrong answer. And a lot of innovation really comes down to, let's start tinkering, start thinking. If you have an idea, start whiteboarding it, start writing it down, start prototyping it, start, you know, building something out of a scrap piece of wood or aluminum, or even start CADing it into a 3D design into the computer, and then see how the simulation really looks like, and then start iterating through it. Innovation really comes down to being an iterative process, coming up and really fine-tuning it till you see the final solution that you really want, that you've envisioned how it looks like. And then after that, you finally see the actual product itself, then this is where you get the eureka moment. Wow, look at this. This is really, really cool thing that you just built, basically. So the key thing is, don't be afraid to be wrong. You know, just start writing it down, start designing it, prototyping it, whatever that flows into your mind, and try to create it into an actual thing. And this is where really innovation starts spurring from, right? Just do it, basically. You have all the tools in the world here. You just got to find you know, the right tool that you want to use, or go to your mentor and say, hey, you know what, I have this idea here. How do I approach this? And this is where we can come in and really help the students out from there to really spur their innovation from that perspective.
Very good. What about you, Steve?
Yeah, kind of similar to William's comment there, especially if it's a new concept, I try and find analogies or, you know, kind of other similar problems, and then try and make a link between the two sets of problems. You know, engineering, as William mentioned, is often about adapting a solution from a completely different problem or situation to meet the current requirements. And kind of a little bit of a jokey, but engineering. A lot of engineering is about stealing ideas and using them in new applications and situations. It's very much a standing on the shoulders of giants.
Very cool. So this is a really important question and something that we get asked a lot. So how do you ensure girls have equal access to learn technical skills and not be placed on like a marketing, social media team, something that's non-technical? Steve?
So for the Woodrow Wilson, it's actually we don't see this, or I personally don't see this as a huge problem for us, and partly it's because we have an all-girls FTC team, but and by the time that they advance to the FOSC team, which is our mixed team, they're already technically competent. Just like everybody else in the team, this is not a girl or a boy problem. It's their skills have matured by that point. And ironically, our girls team has always been excellent on the outreach side and that side of things. Naturally, they drive themselves with that, far superior to our boys team's efforts on things like outreach. The biggest issue I see in general is a general shyness, which affects both boys and girls. And I would team the mentors, we simply include everybody in the same discussions and assessments, and I don't think any of our mentors really distinguish in any way at all. Just treat the students all the same. I think it just kind of comes naturally.
Very good. So how do you guide a student without completing a skill or task for them? Asheesh?
So I think this is a very important thing for the students to work on. So like I always prefer students to have their own space and time. And as I said, I always give them a bigger picture, what their end goal is, and what they can achieve in small steps. So it is very important that they go on small steps and then achieve the final goal. But I'm being a programming mentor, I do see that the students need to learn a lot before they actually produce the real final meaningful result. So, and the students cannot become a programmer on the day one. And that's why, like when I work from elementary school to the high school students, there's a progression which I see over time on the students on different teams, and they learn it over time. Like for example, they learn MathWorks, then they learn LabVIEW, and they learn how to program like CADing. And then there are multitude of programming languages which they learn, like Python and Java. That actually over time, that is the basic fundamental blocks which they have to learn. And then they also, once they do that, then they learn how to do the embedded system programming, like for motor control, for vision applications. And on top of that, I also make sure that when they're working, they also save their work, so that if there is something as fault, then they can go back to their program and then look at it. That means they have to learn how to do source control and how to save their code in the repository so that other kids can use it. So I first make sure that they have the fundamental building blocks. When they have all that fundamental skill set, then they go ahead and learn and work on the algorithms, which will work towards their end goal and to achieve the target, to write the final complete source code for the entire system. And by taking this approach, that making them fundamentally strong, I see that they becomes really good. And then over time, they start accepting big challenges and they work towards it, and they becomes really innovative. So that's like, I feel that that's what works across years. So in robotics, I believe kids just start learning from elementary, then middle school, but they can pick up in the middle and then become a strong programmer as well. And so it's a wonderful tool for them to have fundamentals right.
William, how do you guide a student without completing a skill or task for them?
So can I echo back to what Asheesh was mentioning, right? I think it really comes down to showing them the basics, really going back to, hey, you know what, to solve a problem, we tend to show our students all the way to the basics. So let's say if you need to know how to use the CNC machine in our shop, or how to use a chop saw, or even how to program, for example, we're not going to just jump, just throw them over the fence and let them swim there. We're going to go rewind all the way back to showing them the basics, saying, hey, you know what? You want to learn how to use the CNC machine to cut a specific material. Let's learn about the basics of how the CNC machine works, for example, the technology behind it. How does it work? Does it, it's a big giant machine that moves in an X, Y, Z form, for example, and it cuts through a material bit by bit over time. And this is how you draw it. This is how you CAD it. This is how you load it to the system. And then these are all of the little basic building blocks that you really try to communicate and teach every single student, not just from the CNC aspect itself, programming, it's the same thing, right? You want to teach them the basic programming language, teach them how to use the tools itself, what are the different programming language there are. We have the programming language for the robot, we have the programming language for scouting, for example, and then CADing. So really teach them all of these little basic building blocks. And then from there, they can start thinking about, oh, wow, okay, so this is how it works behind the scenes. This is how the technology works behind the scenes. Then this is where it starts spurring innovation within themselves, where they can start building more building blocks, more complex building blocks in their mind, and try to design bigger items from there. And then this is where they can start completing all of the different skills and tasks to the point where we say, hey, you know what? We just designed this robot in 3D CAD. We just printed out a bunch of 2D drawings of all of the different material that needs to be cut, for example. You students go and cut all of these materials. And these are all the individual tasks that they go through. But the only way that they get to do all of this in a good quality fashion is they all understand the technology behind all of the tools in the shop, how they work, by showing them all of these basics items, basically.
Excuse me, I'm going to step back a minute because I skipped over a very important person, Eduarda. Let me go back and ask you, how do you ensure girls have equal access to learn technical skills and not be placed on a marketing or social media team?
Well, so I'm a mentor to FRC, and we don't have a marketing or social media team. But I have been a judge for many other robotics competition, and I have judged the marketing presentation. And it was very often that I would see that the majority of the girls in the team were in the marketing team. And I think that the role should be assigned according to students' interest. So if girls are interested in marketing, I don't see any problems with that. However, I see that most of the time when girls don't go into technical roles, it's because they feel underrepresented. So they don't want to be the only girl doing that task, right? So I think it's very important for the mentors to empower girls and encourage them to develop technical skills.
Very good. Thank you for that. So did you want to add something?
No.
No, yeah, I was thinking to add, Susan, on that about the girls thing. So the FLL team, which I'm mentoring, is actually all girls team, and that's like bringing the challenge to the girls, and they showed really good from the design to programming to mentoring, to marketing, everything, and they got very good awards at the competition. So girls are like, they can do equally better, and then they can make a full impact on first. So there is nothing stopping them to do the good things. And we have that the same thing in our high school team, the Eagle Robotics, that the girls are contributing every level. So yeah.
Fantastic. Thank you for adding in. Anybody else?
Yeah. For my daughter's FLL team, it was kind of interesting. It was a rookie year when we started, and we had a bunch of 4th graders and 5th graders, and there were a couple of boys who had an opinion about what everyone should do on the team, and they had taken some coding class some point, and so they automatically said, okay, we'll do all the programming, you girls, you do this other thing. And we had a pretty balanced team. We had 5 and 5, but that was a good opportunity to kind of talk to the students and let them know that everyone can do every single role. And we actually kind of almost made it a okay, today all the programming will be done by this subgroup. It doesn't have to be all girls, but could be a mix of girls and boys, but sort of stepping in as adults and kind of making sure that there is no kind of default gender roles that some of these younger students may be exposed to, or they may just think a certain way, but and that may just be because they've not been exposed to other opportunities. And so here, this kind of gives them an opportunity to also see that there's really no fixed roles. Everyone, as was said earlier by Eduardo, if someone's interested in a particular field, they do it. It doesn't mean they do it just because they're a boy or just because they're a girl. So I think even at younger ages with FLL and FTC, that's an important life skill to share.
Absolutely. So thank you all for adding on to that. We really appreciate it. So how do you assess what a student needs from you? William, let's start with you.
Yeah, sure. So the really key thing here is really watch for signs, what the students really need, especially if they're bored or if they're not doing anything, or if their behavioral has changed, for example, or if they just are looking for something to do, for example. And these, you can really pick up these little signs over time as you've mentored all of the students over time, and really pick them up. So the key thing here is that be alert, be there for them as much as you can, be present, and really look and see, hey, you know what, you sound a little bit down today, or you look like you need something to do, for example, or for example, you look like you're kind of lost. You're working on something on a project and you look a little bit lost. It sounds like you really need help here. So let me jump in and see what are the problems that you're having here. What can I do to help you to unblock whatever you're doing and really move forward from there. And really listen to them, to their problems, and just don't ignore them. That's the key thing, is just listening and see what they need, right? They always are looking for someone to look up to, and this is where our job comes in to really help them.
Very good. What about you, Steve?
Yeah, I agree with William there. It's pay attention. I tend to kind of ask a lot of questions of the students. See what their reactions to questions are. See what questions they're asking. Typically, if they're not asking questions, then most likely they either don't understand something or they've given up for the day. So it's really just pay attention and keep engaged with the students, keep asking them questions, and kind of analyze the questions that they're asking as much as the answers that they're giving. That tells you a lot about both their attitude and their understanding as to what's going on.
All right, thank you for that. So how do you deliver feedback to a student? Asheesh?
Okay, so this feedback process, I see that it's it's not like one-time feedback thing. Okay, so the way we work with the students is that every time we meet, we set the goals. And we start with some design discussions, and we have some whiteboarding and all. But when we work together as a team. I'm also like a team member for them. So it is like I work with them. So when we work with the team, we also have breakout sessions. So the students are working, then we have breakouts, and during the breakouts, then we will say, oh, what has happened, how we are progressing, and how we can improve further, what they're struggling with. So we discuss as a team and provide them the feedback, what that can be done to improve further. But at the same time, when I have a good environment with the students, that okay, I'm your team player as well. I'm not just your mentor. Like maybe okay, I'm just sit next to you, and then we solve the problem, and that what happens that they are more confident and becomes more friendly to ask questions. So it becomes like a very important, like it becomes natural to give a feedback process to them, and they can ask questions and I can provide the feedback and they can improve further. So to me, it's like the type of environment we create in our teams to be very friendly. It is very easy to give the feedback so that students learn, and then they are also very open to the discussions. So that's how I approach that, to give the feedback to the students.
Pretty good. What about you, Steve?
Yeah, very similar. Again, it's kind of almost the same as assessing what the students need. It's, you know, I try to show by examples, but also just ask a lot of what if questions, and kind of often give feedback in terms of a question rather than an answer. You know, I'll try not to answer the question directly for them, maybe, but lots of these leading questions and go through the problem. Asking questions along the way to the answer. You know, we may provide the answer, but as long as you're telling them how and why you get to that answer, you know, because sometimes you'll have students that the solution truly is, you know, they're just not going to be able to get from A to B. You know, especially with rookie teams that have no experience to draw on. So you can kind of ask questions and then answer their questions with other questions to keep them thinking. I think that stokes their curiosity in answering you know, kind of giving them that feedback. I also try to use a lot of humor. You know, I don't take life too seriously, and I think that keeps things relaxed and also like makes things a little bit more enjoyable for them, where it's, you know, perhaps not a kind of looked at as a you know, this is an engineering class that I have to pass, and I think if you're giving that feedback in terms of you know, kind of almost you know, as a peer rather than you know, a teacher student or a mentor student, that feedback is absorbed with a different attitude.
Very good. So what do you do when you cannot answer a question from a student? Harshal?
Yeah, so I actually, you know, ran into that because I was a new mentor at the time and didn't have all the answers. And I think that was a good way to let the students know that, you know, not everyone has all the answers, but part of the process here is to learn how to find out. And so, you know, I would say, let's look it up. Okay, I don't know the answer to that, but let's find out, you know, how we do that. And so we would, you know, look up, you know, information online. You know, maybe there's a YouTube tutorial somewhere. One of the great things about FLL community is there's lots of information available online. I mean, and you know, that was a good discussion even on, you know, just be wary of, not everything you read is valid online, but there's still some good tutorials. So we just kind of, you know, walk them through some of the material that FIRST puts out, but also some of the community videos and you know, information about programming the Lego brick. Because again, you know, I was familiar with it, but I wasn't an expert by any means. And so I think that was a good way to kind of show them kind of just how to look for information, so that, you know, even in other parts of as they grow and, you know, venture into other fields, they are aware of how to safely look for information and how to filter things online.
Very good. What about you, Eduarda?
That happened multiple times. And I told them since day one that I really wanted them to, whenever they had a problem or questions, that they should come to me, and that although I might not know how to answer it, I can find someone that can help or can guide them in the right direction to find the answer. So in my team specifically, most of their technical questions were related to electrical and programming. and I'm a mechanical engineer, so I don't have that background myself to be able to help them. And that's actually the reason why I started bringing guests to our team meetings that were electrical and computer engineers, coworkers, and that really helped us a lot. So they were also able to create a connection with them, that whenever they had questions, they could just send an email, give them a call as well. So that worked very well in that sense.
Thank you for that. So what is the best advice you can give to a student who wants to further their education after high school or to get a job? Steve?
So this one's an interesting one. My advice here would be ask questions and learn as much as you possibly can. Make sure you know what you want to do, but kind of more accurately know what is involved in each field or job. What it actually entails. I have a story of a friend that I went to high school with who absolutely loved chemistry. Turns out he didn't. He loved the teacher and the style, not the subject. He did a chemistry degree and absolutely hated it. And now he works in HR. So ask questions, make sure you understand and you have a feel for, what this path is going to lead to. Make sure it's what you want to do. And make sure you truly understand that you're going to enjoy the job and the rest of your life versus like I say, it's you loved chemistry but hated it.
What about you, Asheesh?
So I have I agree with what Steve has said, but I have a very strong opinion about higher education. Like, I believe that kids should go and do higher education unless there is a pressing need for them to go and do a job immediately after their high school. But I believe, and I guide them through and tell them that what the students should be doing by achieving, but if they do their bachelor's or master's or even to their PhD program. The more you can learn in the early part of your life, that is going to pay off in the longer run, and that will help over time. Now, if definitely, if the students also have to understand that what their needs are, but I also tell them, if you have to do a job, then also go ahead and do the higher studies as a part-time. So the studies are not going to fail. It will always going to take you to a longer run. And I have seen so much of change in technology over the last 3 decades. We didn't had a cell phone earlier. Now we have cell phone. We are talking about autonomously driving cars, and being an engineer working in the laytest technology. I see the tremendous growth which is going to see in the technology going forward, and there are so many jobs which will be created by the fundamentals where we are going on this change in human lifestyle. So I believe that in the coming years, in the coming decades, robotics is becoming a very strong application, and students will see a lot of innovations going on. So and FIRST gives, and it is very good that FIRST gives a very good platform for the students to do that, and it's going to create a lot of jobs. So I just encourage students to study as much as they can to make their future bright.
Very good. So what is your best method to inspire students? Asheesh?
That is very interesting question. So sometimes when we work with the students, we say, okay, a lot of students, they come and they say, okay, that we have this competition coming in and we have to go and work towards the competition, right? We have to make this robot to work. We have to program it. We have the timelines, we have the deadlines, but there are off seasons, and also there are a lot of times where students can improve. So the way I inspire, that I want them to create more solutions which can expose them to the new advanced technologies. So for example, when I worked with, I work in machine learning technology right now. So I expose them to say, hey, how they can detect the object. It is you have so many objects out there. So I gave inspire them to create a very simple application where they can use the latest technology of machine learning by doing training and inference techniques and put them on the embedded processors. And my students are able to port latest TensorFlow Lite on embedded platform for object detection. And they enthusiastically do that and capture and create data sets. And these solutions, they help them this kind of exposure, which not necessarily is going to directly put into the competition and win that. It helps them to get to see what is the latest technology, what is the industrial trend is going on, what the technology is going in future, and then and they can see that how it will help them in their practical life. So I try to, during the off-season time, during those periods, I try to inspire them to expose to the newer technologies so that they become curious, become innovative. That's one of the things which I try to do to my students.
Very good. What about you, William?
So the way I start with this is that, kind of go into more like the leadership by example, where you try to first explain to them what's the overall goal that we're trying to achieve for the whole season. And we do this every year before the season starts. We even do this after the season ends to explain, hey, what did we do well? What did we not do well? What should we do better next year? And then take all of this input and feedback and try to roll it over to the following year. And then after that, break it down into further specific items to explain to the students, hey, what are the things that we need to do better next year? What are the specific tasks that we want to get there? And then once you start that framework, understanding all of this little goals there, right? That helps the student. Oh, okay, so I need to do something basically to be successful. And what these are could be for example, could be scouting, for example, right? It may not sound glamorous to most of the new students, but there's a lot of importance to scouting, for example. And this is where, we as mentor explain to them, hey, you know what? Your work as a scouter may not sound glamorous. Sure, you sit there for many hours, you go and observe a robot and learn about a robot, but your work translates really into understanding how are you going to partner up with the other robots, and how are you going to compete? How are your opponents are going to compete from that end, and really try to explain to them why this is important. And this is kind of how you inspire those students to say, okay, so I can now understand why the importance is from that aspect. And then the key thing is that not just explaining to them, but really showing the actual impact, right? So at the end of the day, it's that, hey, once we're done with the competition, we look at all of this data from scouting, for example. We showed how that impacted the competition, for example, how we made positions out of them, and showing the students and really inspiring them from there. And this really can be applied not just for scouting, for example, right? It could be building the robot, for example. It could be like, for example, hey, you know what? We need to do a better job this year to do more detailed CADing on the robot, for example, and really try to show that in action, making sure that you can simulate everything, you can see how everything works, and then you can build them from there. And then this is going to help students to really understand, okay, so these are all of the specific goals in mind, why we're doing this, to really help inspire the students from there.
Right. I'm going to ask you all one last question, and then we've got another question coming in from the audience and a comment. So, is there any other advice you would like to give to students or adults who want to become a mentor? Steve, let's start with you.
Do it. Just do it. You'll learn a lot, and I promise you'll have a great time doing it. Just do it.
Very good. What about you, Asheesh?
I would say that, as I said in the very beginning, the FIRST is a very good platform for students to create skills, to demonstrate, and become successful in their career. It is not just becoming a good engineer. It's about becoming a good leader, a good businessman, entrepreneur, team player, create soft skills, and all about it makes you a good human being. And I do learn from the students a lot. I enjoy working with the students. And I see the students when they are happy, even in small milestones when they achieve, they say, oh, they are happy by that. And then, and I share that happiness with them, and it makes me happy. And that actually, I would say that mentoring the students keep you in touch with fresh minds who have new ideas. It is interesting, enjoyable, and at the same time, a very good experience. I just say that this is wonderful.
Harshal, what about you?
Yeah, I do want to, echo what's been said before, but I also want to mention that all these teams, even though they are participating in a robotics competition, they need guidance about things that are beyond robotics. All of us are engineers here, but we'll all say that the teams need help with, time management, with scheduling. What comes first, what do we do first, and what do we do second, and all of these skills are things that I think all of us as adults in our professional careers have dealt with and do deal with, even though we are not engineers. So I want to really encourage adults, professionals from all walks of life, whether you are in finance or advertising or marketing or communication or teaching, anything you're doing, you have valuable skills that can directly impact these students and make them into effective, adults as they grow in their journey. So if you're an engineer, that's fantastic, but don't wait, or don't think that just because you don't have a engineering degree or you're not a professional engineer that you can't mentor these teams. I mean, there's elementary schools, middle schools, high schools, all across Texas, all across the country, all across the world, where these students need capable mentors, like the ones that we already have, but once. So as Steve said, just go do it.
Very good. Eduardo?
I have two advices. So the first is that you don't have to have robotics experience. So I didn't have any robotics experience prior to first, and that's something that I was a little nervous in the beginning because I was afraid that was something that would give me a disadvantage and so on. So that's something that you should not worry about. And second is, if you have the opportunity to volunteer as a judge for any robotics competition, I think that that's something that you should do because it's going to give you a very good perspective when it comes to advising your team for scoring. Because as a judge, I have seen many teams that were very competent. They put a lot of work in their robots and they did a lot of fancy mechanisms and so on, but they didn't score well because their focus was not on the text, the score sheet and what they need to score. So those are the advices that I have.
What about you, William?
So echoing everyone here, right? It really comes down to don't be afraid. Just carve up time, make it time. We need you as a mentor. There's no shortage of mentors to go and find students to go and mentor here for any robotics team in general, right? You know what it takes to be a student. You've been there before, and now it's your time to really step up to be a mentor. And we try to encourage this with all of our students that has graduated from our program, go off to college, go off to work, to say, hey, you know what? Time for you to come back to step up as a mentor at some point here. And we try to encourage that. And we have a few of those that really came back to be a mentor even while they're in college. And that really helps to transfer that knowledge and also to show that, hey, that they care. And they want to give back to the community. They want to make an impact, right? I think from my end is that what I want to say is that, I volunteer in a Title I school where the key thing here is that really seeing these students here graduating from high school is the key thing here. And that's number one priority. Number two is that seeing them that they're actually the first in their family going to college after that. So understanding and knowing that they can go off and be something even better than what they used to know of themselves, and you be the mentor to really help influence that. Knowing this is really impactful, I would say.
Very good. So here's a question from the audience. So how do you deal with the toxic student? For example, the student that will roadblock tasks or derail conversations or tasks, or generally disrupt rather than help. Anybody want to take this question?
I would like to answer that because I have had to deal with it, not only robotics, but many aspects in my career. Whenever you have the team, you always have someone that's underperforming. Like there's always that one person, right? So I think that the main, the first step is to have empathy and try to understand why is that person acting that way. Because once you understand the reason why that person is acting that way, then you can have a plan on how to fix that issue, right? So let's suppose that you have that's a student that used to be a contributing member of the team and has turned out to be that way now. So that will for sure have a solution. There has to be a reason. Could be a conflict between other members, or it could be that they are not happy with what they're doing or the task that they were given and so on. So there could be many different reasons why people would act this way. So the first step as a mentor is to understand why. And then it goes back to the questions that you have asked, how do you bring the best out of students, right? So once you understand why, then you can have a conversation with them on why they should change or how they could improve to better help the team. Because at the end, it's all about the teamwork and the team performance, not the individual performance. So as long as that individual is contributing to the team and it's not disrupting the work of others, then that's the goal.
Anybody else want to answer that question?
I think the other, just quick, I think it may also very well depend on, which particular age group we are dealing with. Like I mentioned earlier, I mostly worked with fourth and fifth graders, and, they still have a little bit of respect for adults. And so, that always helps is kind of, just talk to them one-on-one. And because I did have one case, not truly toxic per se, but someone who was disruptive or, was a little bossy towards other students, and kind of just taking them aside and asking them, hey, what's going on? If you don't want to be on the team, you don't have to, nobody's forcing you here. But if you want to be on the team, you need to be a team player. And at least I was, I guess, lucky enough that seemed to help. But again, that may not work with a 16, 17-year-old person who's, has their own personal challenges that are different than a 10-year-old's.
Yeah, I would like to add to that is with respect to, okay, there could be some students and that, but when we are working in a team, we also have good teachers around us. Now we are not just mentoring on our own, and then we have the school teachers who actually deal with such situations, and we really get very good help, because even though like we are mentoring, we bring in some kind of expertise, but we also have good teachers who actually deal with the students every day. So that aspect is always taken care of. And definitely, as I agree with Harshal, that we come to that being a good team, and we need to create a good team, and that's how being communicated to all the teams, all the students. Yeah, so that's how it's really taken care of.
Well, got a thank you for answering that question. So now we just have a general comment I'd like to read. Please let the panelists know how much the business and local communities really appreciate what these mentors are doing for First in Texas to fuel the next generation of innovators. I love seeing the passion, confidence, curiosity, and teamwork develop as kids really get into First. Thank you. So I just also want to say many thanks to Texas Instruments for the work you do to change the lives of students and for being a partner to First in Texas. The students will remember what they've learned from you and for the rest of their lives, and will hopefully become First in Texas mentors and volunteers like we've talked about. Thanks for watching today, everybody, and check out our calendar for upcoming events.